Now we want to begin to solve our trig equations. And for this section, we want to find all our solutions. So we're not going to limit ourselves to just the first and the fourth quadrant or the first and the second quadrant. I want any solutions that I can find. So I need to be able to go above and beyond what the calculator tells me. So for this section, since our calculator works in functional mode, we are going to need to create a reference triangle to find the other solutions. If I just put the value that is from my calculator in, I'm only going to get half or sometimes a quarter of the answers. So here are the steps we're going to go through. We're going to write our trig function in terms of sine and cosine, determine what two quadrants our solutions will be in based on all students take calculus, find the first solution using the calculator and draw the answer in the proper quadrant, draw a reference triangle in the other quadrant, and determine the second angle geometrically. And this right here is the important step from what I showed in the other video about how you might have to add or subtract from 180 or subtract from 360. It's not always going to be the answer that the graphing calculator gives you. You might need to do some manipulation in order to come up with the proper reference triangle. So for example number 1, using your calculator, solve the following on the interval from 0 to 360. Check your work graphically and algebraically. So we're going to be using our calculators for this, but since this one is on the unit circle, let's look at it from the unit circle perspective. Then we'll imagine that it's not on the unit circle and go through all the steps in order to solve. So the sine of x is equal to negative square root of 3 over 2. If I go to my unit circle, I know sine is negative in the third and the fourth quadrant. So I'm going to look for that negative square root of 3 over 2 for my y values. And I can see right there, there's my negative square root of 3 over 2. So my answers should be 240 degrees, and they should be 300 degrees when it's all said and done, because those are my answers that are between 0 and 360. So I know before I even start anything, just because this is on the unit circle, x is going to be 60 degrees, and x is going to be, actually it's not 60 degrees, it's 240 degrees, and x is going to be 300 degrees. And I only know that because it's on the unit circle. If it wasn't on the unit circle, I couldn't do that. So let's take, knowing that those answers are final answers, let's work through this algebraically and see if we can come up with those answers. So the first thing we're going to do is write our trig function in terms of sine and cosine. It's already sine and cosine, so it's good. Determine what two quadrants our solutions will be in based off of all students take calculus. And here, since sine is negative, the sign is negative, so we're going to be in quadrants 3 and quadrants 4. We know that's going to be the case. Step number 3. Find the first solution using the calculator and draw that answer in a reference triangle in the proper format. So what we've got here is the sine of x is equal to negative square root of 3 over 2. In order to get x by itself, we're going to take the arc sine to both sides. So now x is going to be the arc sine of negative square root of 3 over 2, and that's what I can plug into the calculator. So in order for me to plug that into the calculator, I need to get my function in terms of x, which means taking an arc sine or an arc cosine to the other side. And here we want the arc sine, or the sine inverse, of negative square root of 3 divided by 2. And if I draw that, I see I'm going to get a negative 60 degrees. So I'm going to draw my reference triangle, and this is going to be a 60-degree angle. Now I said the answer is negative 60, and I just put 60 there. Remember, the negative is just telling us direction. It's not telling us how big the angle measurement is. The positive number tells us how big that angle is. So I can drop that negative sign. I just have a 60-degree angle going in the clockwise direction. But what we can see here is negative 60 was not one of the two answers that we found on the unit circle, that 240 and the 300. And the reason that is because look at my original interval here, from 0 to 360. So this negative 60 can't be one of my solutions. I've got to find a coterminal angle, which means we've got to add 360 to it, which is going to give me 300 degrees. So there's that 300 degrees that I'm supposed to have. It's between 0 and 360. So sometimes your calculator might give you an angle that you need to add 360 or subtract 360 from, depending on, actually just adding 360 if you have a negative angle. Step number 4, draw a reference triangle in the other quadrant that is the same angle size as our first reference triangle. Since sine is negative and we're going to be in the third and the fourth quadrant, I know my second reference triangle has to be in the third quadrant. This angle measurement is also 60 degrees. Now, since whenever I measure my angles here, I'm going around in this direction, what that is saying is my second x is going to be 180 degrees plus 60 degrees. I'm 60 degrees past the 180 degree mark, which is going to be my 240. So there's my 300 degrees and 240 degrees. And that lines up with what we had on the unit circle, so we know we've got the correct answers there. So that's the thought process, figuring out what quadrants our answer is going to be in, taking the arc or the inverse to both sides to get the function by itself, determining one of the answers from the calculator, plotting that reference triangle in the proper quadrant, going to the other quadrant that's got that angle, and then solving by either adding, subtracting from 180 or 360, doing some math there. So we know these answers are correct based off of the unit circle. But it says to check your work graphically and algebraically. Let's start by checking algebraically. And when you check algebraically, you take your answers and plug them back into the original. So what we're saying here is that the sine of 300 equals negative square root of 3 over 2. And we're saying the sine of 240 degrees is negative square root of 3 over 2. Now, you might say, well, that's on the unit circle, so of course it's true. Well, once again, let's say it wasn't on the unit circle. How would I go about checking? And we would use our calculator. So we'd take the sine of 300 degrees, and I see that it's negative 0.866. And we said that it's going to equal negative square root of 3 over 2. So then we'll put in the negative square root of 3 divided by 2. And we can see that's negative 0.866 as well. Identical numbers right there. So we can say that these two pieces are equal, and my answer is correct. So then the other question is, if we know negative square root of 3 over 2 is equal to negative 0.866, does the sine of 240 equal that? And sure enough, the sine of 240 equals that. So checking algebraically is good. The last thing that we have is we are going to check graphically. And when we check graphically, we're going to plug both of these pieces into the calculator we'll graph. So in y1, we'll put the sine of x. And then in y2, we're going to put negative square root of 3 divided by 2. And we're going to graph and see where do the lines intersect. Now, you might run into a situation like this where your window doesn't look quite right, and you're like, well, how do I fix that? I see no intersections there, so I think there'd be no solutions. If you click Zoom and then choose option number 7, Zoom Trig, that's going to resize your window for you. And what this did is it went from negative 360 degrees all the way to positive 360 degrees. And the only piece that I care about is over here, from 0 to 360 degrees. So if I look at this graphically, we've got our sine of x, which looks like that, and then I've got this line. So we said y1 equals the sine of x, y2 equals negative square root of 3 over 2. And there's my 0 right there. So that's what my graph looks like. In order to confirm my answers, I want to find these intersection points right there and see what my answer value is. So I want to find this point and that point. And the x value should be 240 degrees and 300 degrees. The way we check this graphically is we go second calc and we choose intersect. And we're going to move our cursor right at the point of intersection, or as close as we can, and then hit enter 3 or 4 times. Looks like I went a little too far there. Intersect. And you can see right there the intersection is 240 and negative 8.66. The exact same thing that we had before. We'll also then confirm that second intersection by moving over to 300 degrees. We can see the intersection there is 300 negative 0.866. And so that confirms that my two answers are 240 and 300. When I do the intersection, I get that exact x value that I was looking for. So this is 240 degrees. That intersection is 300 degrees. The way we did that was we hit second, and then we chose calc, and then we chose intersect, and we found the intersection. And if my graph didn't look right, what I did is I hit zoom and then zoom trig in order to see my graph in the proper window.